Dear students, we are continuing the fifth module, that is Nyquist criterion. So here, what I want to sum of, I think that last video, okay, the previous video, in that the problem is not complete. Little more explanation is needed. That will complete now, and after that I will go to the new problem. Okay, so here. So we discussed that for k less than 1, okay, k greater than 1, for k greater than 1, so k is magnitude of k greater than 1. So here you got the intersection is at a minus k. So if k greater than 1, so intersection is minus k. So as you can see that intersection is on a real axis is minus k, that is greater than minus 1. So if that happens, what happened? So as you can see that here you get a diagram like this. Here same plot, if k is greater than 1 or minus k greater than minus 1. Okay, so your intersection is minus k. K greater than 1 means minus k become minus 1. So that means this is minus 1 j0 point, minus 1 j0. So the intersection is somewhat left to this. So when you are doing like that, intersection is like this. So the shape of the graph is, you can see the plot is, you can already observe that around minus 1 j0 there is an counterclockwise encirclements. So here n is 1. So here n is 1. One encirclement in the counterclockwise, it will consider as plus 1. If clockwise direction, then you have to consider n as minus 1. So here n is plus 1. And we observed from the transfer function that there is a pole at the right hand of S plane. So here P is equal to 1. P is equal to 1. So our expression is n is equal to P plus Z. Okay. On P minus Z. N is equal to P minus Z. So here P already got. So 1 is equal to 1 minus Z. So you can see that Z is equal to 0. There won't be any right hand side zeros. So we can say that the system is stable. In this case, system is stable. Now for k is less than 1, when k is less than 1, what happened? If k is less than 1, then 1 j0 is minus 1 j0 is here, and intersection is minus k. K less than 1 means intersection is before this. So you can see that there is one clockwise rotations. So n is equal to minus 1. P is 1 here. P is 1. So right hand fold already from the transfer function we got. P is equal to 1. So n is equal to P minus Z. So minus 1 is equal to 1 minus Z. So Z you are getting it as 2. So the closed loop, so we are getting Z as 2. So you can say that the closed loop system is unstable as two roots of its characteristic equation are in the right half of S plane. So this indicates that there are two roots on the right half of S-plane. So this expressions tells the number of this represent the number of encirclement, and this will be positive for counterclockwise encirclement. This is negative for clockwise rotation. P is the number of poles on the right of S plane. Z is number of zeros on the right half of Z plane. So here we got that there are two zeros to the right half of S plane, so it is unstable. So here next we will do the next problem. Sketch the Nyquist plot. This is 8 points. Sketch the Nyquist plot and comment on the stability of closed loop system whose open loop transfer function. Here they are given open loop transfer function g of s into h of s, k into s minus 4 divided by s plus 1 square. Now you have to convert into sinusoidal transfer function. So g j omega h j omega is equal to k into j omega minus 4 j omega plus 1 all square. So here what you can do is you can k into j omega minus 4 into divided by 1 plus j omega square in order to make real term and imaginary terms. You can multiply by 1 minus j omega square. So what you are getting it is, yeah, so when you are doing like that, so you are getting it as you can see that 1 minus 1 plus j omega all square into 1 minus j omega square, the complex conjugate. Now 1 plus j omega is 1 plus j square omega square 1 square j omega square plus 2 j omega. This side it becomes this is multiplied by 1 plus j square omega square minus 2 j omega. Okay, so here this will become 1 minus omega square plus 2 j omega. Here 1 minus j omega, 1 minus omega square minus 2 j omega. Now when you are multiplying it, you can see that 1 into 1 into minus omega square, that is minus omega square, 1 minus 2 j omega, then plus minus omega square, then minus into minus plus omega raised to 4, then omega minus into minus, yeah, minus into minus plus 2 j omega cube. Then in a multiple 2 j omega, here you will get a plus 2 j omega minus 2 j omega cube okay. The next 2 into 2 4 j into j square. So j square is already there, that is again minus minus of minus plus, so it is plus 2 into 2, 4. Omega square. Now in that, minus 2j omega cube, and this will be cancelled. Minus plus 2j omega and minus 2j omega cancels. So 1 minus, yes, omega square minus omega 2 omega square here plus 2 omega square, you are getting 1 plus 2 omega square plus omega raised to 4. So this is nothing but 1 plus omega square raised to square. So denominator, you will get 1 plus omega square into 1. Similarly, when you are multiplying these two, you will get a real part, okay, k into 6 omega square minus 4. Okay, if you want, we will multiply that also. Yeah, k into j omega minus 4 into 1 minus j omega whole square. So this is equal to, yes, so you will get it as, this will be, this term I can expand it, 1 plus 1 minus omega square minus 2j omega. This will be multiplied by this. Okay. So this will be k, we will consider later. This is multiplied by j omega minus 4. So 1 into j omega, 1 into 4 minus 4 minus omega square into j omega minus j omega cube minus plus 4 omega square 2 minus 2 j square omega square j square again plus 2 omega square minus 2 minus plus 8j omega. Now here 8 minus 8j omega plus j omega 9j omega minus j omega cube minus j omega cube four plus 2 6 omega square 4 plus 6 omega square minus 4 okay. So then there is a multiplying term k also there. So both sides you have to multiply by k. Okay, all you have to multiply by k. All you need to multiply by k. So here, what you will get it as? Just see this. So what you will get it as? Real. This will be a imaginary term. So imaginary terms, and this will be real term. So you can put it as k into 6 omega square 6 omega square minus 4 divided by denominator already we calculated as 1 plus omega square whole square, then here plus j omega you can take it outside, so k omega j also taken, this is 9 k omega, so 9 minus omega square divided by 1 plus omega square whole square. So that's why you got this expressions like this. So what I will do is I will stop now, and next video I will continue, okay, the remaining of this problem.